As an engineer, I'll need to think about making something that will work on its own and there won't be many issues with it, so it's convenient for the user to use. Going in small steps is really important. I did research online and I found a Skittle sorter. All the parts were 3D printed and there was some programming involved, and the design was pretty detailed. The only moving parts was 2 motors. We had a color sensor, so that was all we had to deal with electronically. I looked at some code online for using the motors. I found some code for the light sensor as well. I really focused on the mechanism of being able to sense a color with the Skittle and being able to put the Skittle in the right spot. Anything that went wrong, I could troubleshoot using the code for the motors. I could specifically look at the motors and I could specifically look at the light sensor. So I'd had to find that sweet point where they would go in separate locations.
Arduino is a microcontroller that is a very simple plug-and-play model. You can plug in sensors, you can plug in motors, a lot of different circuit devices. It's controlled by its own language, Arduino IDE, that students need to learn in order to program or code with it. Tanner brought a lot to the table in this project. He was able to modify some of the 3D printed parts to better fit his own design. He was able to come up with a new design that seemed to be even better than what he found online.
It's all about trying to put the resources in the hands of students and in the hands of our faculty in ways that make sense. What are the platforms that we have? What are the tools that we have right now that we could use better? And then what are some maybe the new things that we need to bring into play? So we need to make sure that students have a solid foundation in mechanical engineering, in electrical engineering, and in computer engineering. This project really has all 3 of those things in one, but it's also accessible and something that I can imagine a student that's not a graduate student or even an upper class student being able to complete. And obviously Tanner did a great job.
I enjoy not only figuring out how to build something, how to make the mechanical part of it, what's the code that needs to go into it, what's the operation that is needed to make it work. A lot of the more theoretical thinking behind it, not just the physical parts. I'm doing all the basics, the calculus, math, and science and physics. I think there's a lot of application to real-world situations with it.